And now we have a 3D printing presentation.
Good morning. You guys may have noticed that on Headline I invited you all to use our 3D printer, and so far only a few of you have stopped in to even ask about it. So I thought that I'd take a few minutes today to talk to you and give you kind of some background information on 3D printing. Most parts today are manufactured by pouring molten material into molds or through a milling process using heavy and expensive machinery. And about 30 years ago, the technology for 3D printing was developed. Manufacturers were looking for a way to inexpensively produce prototypes for testing. Because once an expensive mold is created, you can only make that one part with the mold. So to try out new ideas, it wasn't particularly cost effective. So they have been using it for a while, but the 3D parts that were being produced were still kind of rough and not really ready. But in the last few years, the technology has really advanced. And about 2 years ago, the technology advanced so much that the cost dropped so much that even we can have our own 3D printers on our desktops, like the one we have in the other room. So how does 3D printing work? Well, it all starts with a digital design. And this software allows you to manipulate 3D objects in 3D space, and you can either create your own or use, the scene stuff that's there. Okay, so let's say that the object that you want to create is a cylinder. Okay, and so you build your cylinder in that software, and then the software slices the object into really tiny micro layers. And each layer will print on the 3D printer one layer at a time. So like the very bottom of the cylinder will print first. And then the material mostly, well, at least our material is plastic, but there's lots of different materials we use. So the plastic prints and melts, and then the printer goes back over and it prints one layer at a time, and each layer melts to the one below. So you end up with a 3D product. The oldest type of 3D printers, the oldest type is called stereolithography, and that starts with a vat of ultraviolet curable resin, like this resin, and there's a laser that comes from the bottom that prints on the bottom of the resin, and the part actually is dipped in, so it adds a layer to the part each time. And this is the oldest technology, and most of it's not used as much anymore. This one uses a powdered material, usually some kind of powdered plastic, that when it's hit by a laser from above, it melts the powder to create that first layer. And then after one layer is printed, then the machine spreads powder over it again, and then the next layer is printed. And what's cool about this is that in the spaces where there's no plastic, where the plastic's not hard, the powder stays there. And then so if you're creating like something hollow, the powder supports the structure until it's all done. And then when it's finished, the powder gets raised out of the printer, and you just kind of dig through the powder to get the object. And all that powder is reusable again, so it doesn't go to waste. The kind of printer that we have, this is our printer, and this one works by using plastic filament that's on a coil. You'll see that there's the coil, and the filament goes up through a nozzle that heats really hot and melts it as it comes out, and then spreads it on that print platform. And this is printing one layer at a time, and then it'll go over it and print. This is obviously a time-lapse photography, but I don't know if you can see that really well, but that's like a whole Victorian building. So that's what our printer is. So 3D printing is the hottest topic right now in technology, and everyone is getting on the bandwagon. And these are plans for a printed house that were developed by an architect in Holland, and the idea was to print this what the house would look like. They could print it at one time, but since the machinery is scalable. This is that actual one. You can see that they could theoretically make it as big as they want. This is a machine that builds parts for houses, and that's printing in concrete. So the house is not particularly beautiful, this one, but the promise is there for the future.
So how do you turn this into a jet engine part? Walk me through.
Well, we start with a very fine metal powder, and we load this material into what we call an additive metal machine.
And this is deceptive because this is very, very fine powder, but it's extremely heavy.
What this material is capable of doing is resisting high temperatures. It's very high strength, so yeah, this is actual metal material just in powder form versus in a plate or bar form that most people are used to seeing.
More than 6,000 of GE's next-generation jet engines have been ordered by customers like Boeing, Airbus, and Lockheed Martin. By 2016, the new engines will contain a 3D printed fuel nozzle that is lighter, more efficient, and could save companies big bucks. GE may be on the brink of a new industrial revolution as it makes manufacturing faster and more cost-efficient right here in the U.S.
And this is where the magic happens. This is where the laser beam comes down and hits the surface of the metal powder and consolidates it into a solid component.
Within the next decade, the plane you'll be flying on will likely have a jet engine containing wholly 3D printed parts.
We're here at the 2014 IMTS show, and we're going to show you how we're going to turn this into the world's first 3D printed car. We're working on the assembly phase of our 3D printed vehicle. It's the world's first 3D printed vehicle. It was 44 hours to print the body and the chassis all in one piece.
This emerging technology will enable future 3D printers to output synthetic human tissue and even entire organs. Bioprinting may therefore trigger a medical revolution. Most people are familiar with today's inkjet printers. These are loaded with cartridges of ink that is sprayed onto paper to produce text and 2D images. In a similar fashion, future bioprinters will be loaded with cartridges of living cells. These will then be output from a bioprint head that will move left and right, back and forth, and up and down in order to produce a 3D object. Bioprinters will output many types of cells, as well as a dissolvable gel to support and protect the cells during printing. Organs will then be built up in a great many layers. Over several hours, a complete replacement kidney, liver, heart, or other body part will thereby be created. Today, one of the pioneers of bioprinting is Organovo. Here, scientists have already bioprinted experimental human blood vessels and even animal cardiac tissue.
So it's also a big thing in prosthetics, and it's being used very successfully. So they could use, they're now laser scanners, so they could scan somebody's left leg and then make an exact matching right leg out of plastic. In this case, the leg is not just functional, but it's also artistic, which is also kind of a new thing. And also for children, artificial limbs have been very, very expensive because the kids grow, and every time they grow, they would need a bigger size. So this is a really good low-cost option, and once again, this is being used like crazy all over the world. And even our feather friend here has benefited from 3D printing. And even the food industry has gotten into the game.
designer, but now that I'm seeing the possibilities of this technology, you start to see the world differently and you start to reimagine the objects around you.
People are taking the power of creation into their own hands.
Boom, open up your little skull, pull out your idea and create it. Like that's what Shapeways does in a nutshell.
3D printing is a way of making things element by element additively. The things that we're designing, you can't make any other way.
I can make objects bigger, smaller, stranger. There's no limit to the variation you can apply.
I suddenly realized how much I was restrained by a lot of the technologies that were around before.
When something new comes to this home, she asks, have you bought it or have you made it?
If you look around us, we can buy any product we need to do whatever we want. What's missing, however, is our personal input into those products.
We have an idea, and then in the mail, the idea comes sort of as an object, and that's never existed before.
As a designer, you can concentrate on making the best object, the best product that you can, and Shapeways does the rest.
So we can make one of something and test it out. And all of this doesn't make any difference because there's no tooling, there's no molding.
There's no investment for a designer. It means also you can innovate faster. There's no penalty for innovation.
This gives rise to a whole new way of solving problems.
It's mind-blowing to think that we can build something today that was literally impossible yesterday.